Okay, so last thing we're going to finish up for this week is 4.1 part 2. So we talked yesterday about the 6 definitions of the trig functions, sine, cosine, and so on. Today we're going to use those to actually find out how long sides are and how big angles are in a triangle. Okay, so to solve a triangle means to do what I just said. How long are all the sides? What is the measure of every angle? So there's 6 things. 3 sides, 3 angles. Okay. In order to find those things, they have to give you some information to start with. Okay. In fact, they have to give you at least 3 pieces of information. If you're solving a right triangle, what piece of information do you already have in every problem you're solving? Yep.
90 degrees.
You have a 90-degree angle. Okay? So in addition to a 90-degree angle, they have to give you 2 other pieces of information. So you'll always have 3, the 90, and 2 other things. Either, in addition to the 90, they'll give you another side and another angle, or they could give you both sides. But the point is you have to know at least one side. Okay, imagine if I gave you an equilateral triangle and I said the angles are 60, 60, and 60. I just gave you all the angles. Tell me how big the sides are. Why can't you do that? You don't have a side to start with. So if I just said to you, here's an equilateral triangle, the angles are 60, 60, 60, all you know is the sides are the same. You don't know if they're 2, 2, and 2, or 12, 12, and 12, or you don't know. So you've got to have at least one side to start with to get scale. Okay? So what we're going to do is we're going to make a sketch. That's going to help us determine what's opposite, what's adjacent. And then after we make a sketch, we're going to put our information in a table just to organize what we know and what we are being asked to find. Okay, so other than that, really that's all I need to tell you. Okay, we'll just do 3 examples. We'll do one of the type where I start you off with a side and an angle. Then we'll do one with the 2 sides, and we'll finish up with a word problem. At least that's my plan. Okay, so there's the information they're giving us. Now remember, we only know 3 things. Even though it says 2, you're solving a right triangle. So you do know that there is an angle that's 90. So this is the case where they're giving you a side and an angle. And we have to find everything else that they haven't given us. Okay, so there's our chart. 3 sides, 3 angles. What I've done is I put boxes around the things I don't know. I don't know A, I don't know C, I don't know B. I filled in what I do know. B is 2, alpha is 40, and the right angle, I don't have to give a name to it because it's just the right angle. So I just call it the right angle. Okay, let's make a sketch. So the sketch is just going to help us to visualize what's opposite, what's adjacent, and where the hypotenuse is. It doesn't matter how you draw your triangle. If you want to flip it the other way, that's fine. You just have to make sure of certain things. You have to make sure that side A is across from which angle? Anyone remember? Side A is across from
Side B.
Well, B is going to be across from something else, but A is across from which angle? Yep.
Alpha.
Alpha. That's why I set it up in rows. When you draw your triangle, put A across from alpha. We're going to put B across from yeah, go ahead, Austin.
Beta?
Yeah, we're going to put b across from beta. And I know b is 2, so I'm going to fill that in. B across from beta, and that leaves c. So there's my diagram. Okay, so now I can kind of visualize what's opposite 40, what's adjacent to 40, and where the hypotenuse is. Okay. What could I find first out of those 3 boxes that wouldn't really take too much work? You probably should have been able to do it before I even explained anything. Yeah. Luke.
Beta.
Yeah, we can find beta. How would you get it?
Subtract 40 from 90.
Yeah, we know that alpha and beta have to add up to 90. So, and the right angle is 90. So there's your total of 180. So subtract 40 from 90, and what does that give you? 50. Okay, so beta is 50. Now, I'm not going to label that in the diagram. I'm just going to leave the diagram with the information that was given. I have a choice now. In order to find A and C, I can either use alpha, that'll work fine, or I could use beta. That would also work fine. Which angle do you think is better to use? Alpha or beta? Because they'll both work. Oh, Sam, any thoughts?
Beta.
Okay, how come?
I don't know.
You don't? Okay. Anyone have a thought that they could explain their reasoning? Yep.
Because you don't know what A is, and you already know what B is. Like lengthwise.
So as far as finding A, we don't have to worry about B. But we have to worry about which angle we want to use. They will both work, but I have a very good reason why you should use one of those angles and not the other. Anyone have a thought? Which angle was given to you? Alpha. Okay. What's the difference between something that was given to you and something that you found? Something you calculated. Yeah?
You don't know if the one you found is correct or not.
We don't know if beta is correct. I mean, that's easy enough. You should know it's correct. But what if you made a mistake on beta? So if you use beta and you made a mistake on it, what's going to happen when you use it to find other stuff? You're going to be wrong on everything. So the goal with right triangle trig is never use something that you found to find anything else. Always go back to what they gave you because you know it's correct. Okay? So that's why I would stick with alpha. So we're going to do everything from the perspective of the 40. So we have to use the angle they gave me, the side that they gave me, and now if we're finding A, we're going to use that side. So when you're setting up an equation, there's always 3 things involved. The 2 things they gave you, and the 1 thing that you want to know. Okay. So let's set it up to find A. All right, so find A. So we have a choice of 3 trig functions. For today, you're only going to use sine, cosine, or tangent. You're not using secant, cosecant, or cotangent. So we have to decide which trig function would work with the 3 things I've circled. To do that, we have to figure out the names of the 2 sides that I circled from the perspective of the 40. So your choices are opposite, adjacent, and hypotenuse. Brady, what's the side that we've labeled? That's opposite. What about the side that we've labeled 2? Adjacent. Now, out of sine, cosine, and tangent, there's only one of them that has opposite and adjacent in it.
Tangent.
It's tangent. So now we can set up our equation. The tangent of your angle, always plug in your angle, tangent of 40 equals, tangent is opposite over adjacent. Opposite is A, adjacent is 2. Right. Now we just have 1 step left to get A by itself. Jermichael, how would I get A by itself there?
I would say Times by 2.
Yep, because we've divided by 2, we want to get rid of that, so we're going to times by 2. Times by 2. And there is your answer for A. We need to type that in on a calculator. This we will round off to 2 decimal places. First thing I have to check is I'm typing in an angle. Anytime you're working with an angle, check your mode. Is this problem a radian? No, that's 40 degrees. All the triangle problems we do in this section are going to be in degrees. Alright, so let's type it in. 2 tangent 40. 2 tangent 40. I still got to change my mode to degrees. As long as I don't hit enter, I can still change it before I hit enter. Right, and we get a side length of 1.68. Okay, 1.68. Okay, now we have 2 out of 3 sides. What theorem could I use to find the third side? Because this is a right triangle. Oh, Brianna?
Did you say theorem?
Yeah, what theorem?
Pythagorean?
We could use the Pythagorean Theorem, but why do you think I'm going to tell you that's not the best idea? I think we should find C a different way. Yep.
Because we've already recalculated 1.68.
Right, you calculated 1.68. So even if it's right, it's rounded. So if you use that to find C, best case scenario, you just get an answer that's not as accurate because you already rounded A. Worst case, you found A wrong, and now C is just completely wrong. So we're going to find C the same way we found A. Take the angle that was given, the side that was given, and now circle the side you want to find. So focus on what's in red this time. Okay, we already know 2 is adjacent. We just wrote that last time. What's the name of side C? That's the hypotenuse. Now we're setting up an equation that involves what we know, the adjacent, what we want to know, the hypotenuse. So what trig function involves adjacent and hypotenuse? Forget about opposite, because we already did. That's A, and we're done with A.
Cosine.
Cosine. So now to find C, the cosine of your angle equals adjacent over hypotenuse, 2 divided by C. And what really ends up happening here is the C and the cosine 40 can just switch places. And you get C equals 2 divided by cosine 40. Okay. The first time I'll show you why that works, but from now on, I'm just going to flip the C and the cosine 40. Okay. If you didn't know that, your first step would be multiply both sides by C. So now you have C cosine 40 equals 2. But we don't want C times cosine 40. We want to get just C. So now move cosine 40 to the other side. Opposite of multiplication, division. Divide by cosine 40. Divide by cosine 40. And that's exactly what I told you C would equal. 2 divided by cosine 40. So from now on, I'm just going to switch the letter in the bottom with what's on the other side. As long as you have a fraction set up like this, you can always switch x and z. You can always just switch those two, and you haven't done anything wrong. All right, so let's type that in. 2 divided by cosine 40. We get 2.61. A couple things you should check real quick. The biggest side should be across from the biggest angle. Yep. Smallest side should be with the smallest angle. Looks good. And then if you add any 2 sides together, they have to be bigger than the third. Otherwise, your shape is not a triangle. That doesn't guarantee that we did it right, but at least it guarantees there's not something obviously, like, really wrong. Okay. So if I add 1.68 and 2, it's 3.68. That's bigger than C. 2 and 2.61 is 4.61. That's bigger than A. 1.68 2.61, that's 4 point something. That's bigger than B. Another thing you could do if you had extra time to check your answer is check the Pythagorean Theorem. Use it to check it. Try a squared plus b squared and see if you get c squared, or close, okay, because you've rounded. Okay, so that's a good way to check your answer. Okay, so that's an example of solving a problem when they give you a side and an angle to start with. Any questions on that? Okay. So that's another one with a side and an angle. You might be like, well, wait, didn't they give me two angles? Yeah, you always have the 90. The 90's in every problem, so that doesn't really help you. Okay. So let's try this one. This is example 2. This time they've given me a side, and an angle. It's a little different. What can I find right away this time? And I'm okay with using this theorem. I'm going to ask you why. Yep.
C.
I can find C right away using Pythagorean Theorem. How come I'm okay with Pythagorean Theorem this time? I wasn't okay with it last time. Yep.
Because you have A and B, and you have A squared plus B squared equals C squared.
Right. Everything I'm going to plug into the theorem is given. I didn't calculate A, I didn't calculate B. So I'm using stuff that was given. So let's find C. Can you set it up for me, Kyle?
Absolutely. So 3 squared, which is 9, plus 2 squared, which is 4, equals 13.
Well, we need a variable in there somewhere. So we can do that, but what is that equal?
Square root of 13 is C.
Yeah, the square root of 13. So we want to put equals c squared, and then square root each side. And the square root of 13 is c. And we've been doing decimals, so let's just round that off. 3.61. Now that we found C, forget about it. Don't use C to find anything else for this problem. What I would do, though, is make a sketch. Unless you can visualize what's opposite, adjacent, all in your head. Some people can. Some people need a little help with that at first. So I'm going to put A, B, C I'm not going to label because it wasn't given. What is the name of the angle across from the 3? Oh, Ben? What angle always goes across from A? Beta goes with B. So think of it, they start with the same letter. Beta, B. Do you remember the name of the other Greek letter?
Alpha.
Alpha. Alpha, A. Okay, it starts with the same letter. Okay? Alpha, beta. Okay. Now, it doesn't matter which one we find first. So, Tanner, do you want to find alpha or beta?
Alpha.
Alpha. Okay, so we can find alpha first. So that's the unknown. Every trig equation you set up involves circling 3 things. So you can have one unknown, the other 2 things have to be known. So always use what they gave you, and then circle what you want to find. And that's perfect. I have 3 things, only one of them is unknown. What's the name of the side that's 3 units long? Is it opposite, adjacent, or hypotenuse?
Opposite.
Opposite. What about the side that's 2 units long? Jordan?
Adjacent.
Adjacent. And Jordan, can you tell me what trig function would involve opposite and adjacent?
Tangent.
Tangent, yeah. We're staying away from sine and cosine because those involve hypotenuse. We do not want to use hypotenuse because we don't know if it's right. I mean, it is right because because we did it together and I'm pretty sure we didn't make a mistake. But again, don't use it. Okay, let's set up our equation. Tangent of alpha equals opposite over adjacent. Now look at that equation. Look where the variable is. And then look back at the other one we did. The variable was in the fraction, either in the top of the fraction or the bottom of the fraction. This time the variable is not in the fraction. The variable is inside the tangent function. Okay, think of it like this. That variable is inside the square root function. It's protected by square root. So the only way to get rid of square root is to find another function that cancels square root. Square. Okay, we did that earlier when we solved using Pythagorean Theorem. Square and square root cancel each other out. Okay. Alpha is protected. It's inside the tangent function. So how can we cancel out the tangent function? Yeah?
Inverse tangent.
Exactly. Take the inverse tangent. We are not multiplying here. Multiplying is something you can do with numbers. You can do it with letters. You cannot multiply by a word. That doesn't make any sense. We are taking the inverse tangent of the entire left, and we're going to take the inverse tangent. Take means to put something into it, plug something in. I'm going to take the inverse tangent of what's on the right. Inverse tangent, regular tangent cancel out. That was one of our formulas from yesterday. I think it was like formula 6a or 6b. It was one of those. And now we just type it in. Take the inverse tangent of 3 over 2. So second inverse tangent, 3 over 2. So it's 56.31 degrees. Now, if you were running out of time, what you could do is just subtract that from 90. Pray that you got alpha right, and that would give you beta. So before we solve for beta, really quick, I can just check and see what I think it should come out to. 56.31. I think it should be 33.69. So keep that number in mind. If I get that number calculating it the way we just did alpha, then if we get the same answer 2 different ways, then we're pretty sure it's right. Okay, so 33.69. Just keep that in mind. Okay, so now let's find beta. So I'm going to circle the angle and the 2 sides. Now, what we did is we circled a different angle. So think about in that triangle, you just walked to a different spot. So that's like facing this way, and now facing this way. The perspective changes. So what's the name of the side that's 2 units long now from the perspective of beta? 2 is now the opposite. What about 3? Nathan?
You got me.
Well, what are your 2 choices that are left? What do we name? Do you remember the names of the 3 sides in a triangle?
Oh, yeah.
Opposite, adjacent, hypotenuse. We've already used opposite.
Hypotenuse?
Nope, the hypotenuse is always across from the 90. So remember, hypotenuse is an absolute term. It's like if I asked you in this room, which way's up? Doesn't matter if you're facing this way, up is that way. If you face the door, up is still the ceiling. Left and right change places, depending on which way you face. So opposite is now the bottom. Adjacent. Remember, adjacent means right next to you. Okay? So adjacent is the side that's right next to beta, but it's not the hypotenuse, because that's across from the 90. Okay. Questions on naming the 2 sides? That's important, because we're going to get those names right, so then we can get the trig function that we use right. So Justin, we've got opposite, we've got adjacent. Same 2 sides we just had last time. What trig function is that? Which one?
Tangent.
Yeah, it's tangent. Same function again. The only difference is opposite and adjacent switch places. Let's find beta. The tangent of beta equals opposite over adjacent. So now instead of being 3 over 2, it's going to be what over what? Yep.
2 over 3.
2 over 3. Take the inverse tangent of each side. You're basically doing the same thing we did before. And we're hoping to get 33.69. Let's see if we do. Inverse tangent, 2/3, 33.69. Because I got the same answer 2 different ways, I'm almost 100% positive that it's correct. So that's an example of being given 2 sides. Whenever you have the 2-side type, you always have to use inverse trig, like we just did. If they give you a side and an angle, no, you're never going to use inverse trig on those types. Look back at our first example. Okay, so you only use inverse trig on the second type. Okay, so I've done one of each type. Let's finish up with a word problem. Okay, it says you're leaning a 20-foot ladder against a house. The angle between the ladder and the house is 17 degrees. How high will the ladder reach? Not how high you can reach, because maybe you're standing and you're a little higher than the ladder. Just pretend, where's the top of the ladder? Okay. Now, how come it's not 20 feet? It's a 20-foot ladder. How come the ladder's not 20 feet high? Yeah.
It's not completely vertical.
Yeah, it's not vertical. Good luck climbing it if you put it vertical. See what happens. But you got to put it at a little bit of an angle. All right. So what do you think we should do in that? With all that information, it would be a good thing to do to maybe represent it a little differently. Yeah.
Probably draw it.
Yeah, draw it out. When you draw it out, you're looking for a triangle. Somewhere you're going to have a right triangle. We're going to assume that this house is built correctly and that the walls are perpendicular to the ground. That's not always true. If you look at the Leaning Tower of Pisa, it's leaning. It is not perpendicular to the ground. But we're not going to assume anything strange like that. Okay, so there's your ground. Here's your house. And it says we have a 20-foot ladder leaning against the house. Okay, so I'm going to kind of exaggerate it a little bit. There's my ladder. Okay, that's 20 feet. I'm going to assume that the building is perpendicular to the ground. It says the angle between the ladder and the house is 17 degrees. Okay, so we're focusing on this triangle. Where is the angle between the ladder and the house? Is it at the top or is it at the bottom? Yeah, it's the top. The one at the bottom is the angle between the ladder and the ground. Okay, we're talking about this angle right there. How high will the ladder reach? That's this. So let's solve for A. So we've got 3. We're going to circle the 3 things. The 20 was given. 17 was given. A is what we want to know. Could we find this other angle if we wanted? Sure. Did they ask for it? No. So I'm not worried about finding the other angle. So let's label our sides. Okay. From the perspective of the 17, let's start with the 20. So the length of the side that's 20 units is my... It's my hypotenuse. So now in your head you should be thinking sine or cosine. Those both have hypotenuse. Now we're going to narrow it down. What's the name of the side that we've labeled A? Yep, Alan? Adjacent, good. Hypotenuse, adjacent. Which trig function has those two? about pace?
Cosine.
Cosine. Can you set up my equation for me to solve for the height?
17 in the parentheses.
All right.
And A on top and 20 on bottom.
A on top, 20 on bottom. Multiply both sides by 20. And if you place the ladder at a 17-degree angle to the house, that is how high it will reach. So it's going to be a little below 20, but not that much below it. As this angle starts to get bigger and bigger, all of a sudden it really starts to kind of drop off. But from like 0 up to like 20 degrees or so, it doesn't really drop the height of the ladder that much. Let's see. So 20 cosine 17. The ladder is still, it's almost dropped about a foot. So 19.1 feet. Okay, kind of a weird measurement. We don't normally write tenths of a foot when we use English units. So a tenth of a foot, that's like 1.2 inches. So it's like 19 feet 1 inch, roughly. It's close. Okay. Any questions on that? Perfect. So that's 4.1, part 2. Okay, so homework tonight or this afternoon, whenever you do it. Page 255, 31 to 39, just the odds. It's all odds. 43, 47, and 51 to 55 odd. Okay, I will not be having extra help today, obviously, due to the weather. But I will answer any questions on the next time we have class. If we have class tomorrow, the plan is just a review day, just go over some stuff. If we don't have class tomorrow, we'll have the test on Friday. Okay, we are done all the material for